series called TREES, which stands for Talks on Renewables, Empowering Earth and Sustainability from the Global Center of Excellence in Affordable and Clean Energy at IIT Dharwad. The Global Center of Excellence in Affordable and Clean Energy, GCoE-ACE, was conceived in 2021 by IIT Dharwad and Selco Foundation as a means to drive technology development and deployment in the affordable and clean energy space, especially for underserved sector of Indian society. The center's efforts span clean energy generation and storage, energy efficiency and economy, end-use optimization, and allied socio-economic challenges, particularly in peri-urban and rural regions. The center is supported by the Principal Scientific Advisor, PSA Office, Government of India, and CSR support from organizations including Honorary and Ingenious. To foster an inclusive technological innovation ecosystem in these areas, the center is looking for related problem statements and innovative solutions through an innovation challenge called as Catalyze Tech. The problem statements may be from sectors such as livelihood, agricultural, allied agricultural industries, resilient micro businesses, built environment, health, education, etc.
Thank you, Dr. Dheeraj. At the outset, I thank the organizers for inviting me to give a talk as a part of the TREES. My talk is on solar 4D design, development, demonstration, and deployment approaches for indigenous solar technologies. Essentially, the 4D approach, how we implemented at IIT Madras, as far as the solar technology is concerned, that I'm going to give some glimpses or little more details of the challenges and opportunities in developing indigenous solar technologies. I hope you can hear me well.
Yes, Professor.
Yeah.
Yes, Professor, you're clearly audible.
Yeah. So
Professor, there is a small bar on this stop sharing, and then there is a minimization. Yeah, minimization button. So yeah, thank you.
Yeah.
Yes.
So then, thank you very much. And there are several problems which we are facing for next 5 decades. The problems which you can see here is energy, water, food, environment, poverty, terrorism and war, diseases, education, democracy, and population. But as you know, that the population is growing rapidly and exponentially. So, but if you look at the first problem is the energy, and of course it's more relevant to the activities of the center. So, but the energy, the present energy scenario is basically driven by fossil fuels. So therefore, it is the problem of energy cannot be addressed in isolation. It is always with the environment. So the energy environment interactions are important. The energy can solve many of these problems because you know that the energy became a geopolitical issue. That's why you have seen across the world a lot of unrest happening, wars happening because of the this commodity, the energy. So therefore, the world's primary energy is growing rapidly, and the energy consumption mainly represent the standard of living of any individual or in any country. So therefore, the energy consumption is increasing because of the, of course, one of them is the population growth, and the other one is industrialization, and of course, the final one is the increase in standard of living, because per capita energy consumption is increasing. So therefore, the overall energy consumption is also increasing. So therefore, it's important to come up with a solution for the energy problem. But of course, the another environmental issue also need to be addressed in tandem with the energy. So I'll give you quickly how these energy sources are grouped and what are they. And the energy sources are broadly grouped into two, that is celestial or income energy. The celestial energy means that the energy which is reaching to the Earth's outer which is reaching the Earth from the outer space, which includes several energies which are coming from the outer space. Those are solar and lunar energies, which we refer them as a non-depletable, electromagnetic, gravitational, particle energy from stars, planets, and the moon, and also potential energy of meteorites entering into the Earth's atmosphere. These are any energy source which is coming from the outer space to the Earth is referred as a celestial or incoming. Most of the renewable energy comes under this category. The next one is the capital energy, the energy which exists already in or on the Earth, mainly atomic energy, that's fossil fuels, and of course nuclear. Apart from these, there's untapped renewable energies, geothermal. So if you look at that, the present primary energy consumption is based on the fossil fuels. Then if you look at the reserves, they are unevenly distributed across the world. But if you classify these reserves into 4 categories, as renewables are non-depletable source, fossil and the nuclear, both fusion and fission-based fuels, isotopes. But if you look at the system hierarchy, energy system hierarchy, if this energy, this is the energy system hierarchy, which starts with the energy source to the energy equipment here, and through energy carriers. And the energy source can be mainly the primary energy source, which includes both fossil, renewable, and nuclear. So the fossil fuels are primarily driven by the coal, oil, gas, and then the biomass, and the nuclear, and you have renewables, which includes solar, wind, biomass. So therefore, these primary energy sources are transformed into secondary energy carriers, which mainly the high quality energy is the electricity. The other one is the liquid fuels, which is further transformed into the utility scale energy source for application. So therefore, this application can be based on the consumer choice. It could be for the buildings, or it could be for mobility, or for any other applications. So in this process, like conversion process, primary to secondary and subsequent utilization, and there are substantial inefficiencies involved at every location, every conversion. So therefore, it is important to address the problem of that. If you look at the energy sources and services through the timeline, as I mentioned just now, the primary energy majorly controlled by the fossil fuel. So if you look at the pre-industrialization, the industrialization started somewhere 1870. Pre-industrialization, the major energy source was the sunlight. That is the source for actually feeding the, it's a fuel for feeding the energy in terms of this animal force. But subsequently, 1870, the commercial utilization of fossil fuels has started. So since then, the energy conversion and transformation have substantially improved and evolved commercially. So therefore, as the energy consumption increased rapidly, obviously it has adverse implications on the other side. So if you look at this, the energy services and sources to the timeline, as we move forward, then the quality of the fuel is increasing. And if you look at the coal was started and then subsequently gasoline, as we move from coal to gasoline, obvious thing is the constituents, mainly the calorific value or end use efficiency is improved. So in the main component for the end use efficiency is the hydrogen. So if the hydrogen content in any fuel is higher, obviously it will have a higher calorific value, a higher end use efficiency. So the future fuel could be the hydrogen. That's what we are talking about. By 2070, India is India wants to become a net zero country, net zero energy country. So therefore, by 2070, it has to be a net zero scenario. So therefore, we have to explore various options for the energy scenario. So energy consumption or energy demand. So the hydrogen is ultimately the future fuel, but if it comes from the green way, so it is a green hydrogen. We are talking about green hydrogen through the renewables. So that's what this is one of the important options. These are the important options for hydrogen production. Either sun, biomass, or wind. Of course, some part of the nuclear can also be used, but it has to be a proper mix of all these sources. If you look at when we are talking about the future energy scenario is primarily driven by hydrogen. That's what a lot of companies are working on that. But if it is through green route, it is better. So therefore, if you look at the global energy potential across the world, these are the potentials which are represented. Each of these fuels are represented in the circle with the appropriate numbers here around this. And the present energy demand is this, and this energy demand is being supplied by various sources. And of course, if you, as you look at that, these the black, dirty kind of scenario, which is based on the fossil fuels, what they give out of that is important. So therefore, the fossil fuel can supply some larger extent for near future to the world's energy consumption. But as I mentioned earlier, the environment is a major concern. So therefore, it is important to utilize such a big circle, which is having huge potential. This can be abundantly, this is abundantly available and can be utilized to meet the entire world's demand. So therefore, the solar is one of the important option for energy supply for the future. And if you look at the energy demand and prosperity, wherever the highly illuminated location, this is a night lights picture. This when you look at the globe in the night, it looks like this. And wherever the highly illuminated regions are there, that means they are energy rich and energy demand, very high energy demand. And of course, when you have a high energy demand, obviously there are prosperity is also there. So therefore, they are wealthy countries where the energy demand is higher. And still, so there are many countries under darkness. So we call them as energy poverty. So still many countries are under energy poverty, and which includes the Indian subcontinent and SAARC countries. Like the several million people are still dependent on biomass as the primary energy source. Mainly here, the meaning of primary energy means the primary energy requirement for human survival is important, and one of the most important energy requirement for human survival is the food, and that food is being processed by fossil fuels or biomass. That means cooking of food. So the elementary food processing requires huge amount of energy. Apart from that, the high quality energy like electricity, it has to be properly distributed and accessible. So therefore, still there are several million people do not have access to the electricity. So therefore, it is very important to come up with a sustainable energy solution for that. Then if you look at the international context, as far as the energy scene is concerned, we have high energy prices and security of supply concern, because you know that the security, as we are independent, as we are mainly dependent on imports, obviously there's a supply shortage, and supply security is a major concern. And climate change, as we over dependent on the fossil fuels, the climate change is a major threat. And the demand is also growing up rapidly because of the industrialization, improving standard of living and population growth. And apart from that, resource nationalism, geopolitics, we have seen recently how the world is facing now geopolitically, because the energy is the major issue for this. And of course, the control over the energy sources. So therefore, this unrest create this scenario may create unrest among the countries. So therefore, it is important to know what are the basic goals and drivers as far as the energy is concerned. So the goals for energy is energy accessibility, energy availability, energy acceptability. The drivers are mainly GDP, energy demand and energy supply, and they are dynamically linked with demography, environment, institutions, and prices and technologies. So then they have to be based on mainly availability, security, acceptability, of course, effectiveness, efficiency, accessibility. All these plays an important role, including affordability. So therefore, the 3A, this is called 3A criteria. 3A criteria is very important, but of course, if you look at holistically, it's a 6A criteria, which includes energy accessibility, affordability, acceptability, adaptability, appropriateness, assurability of energy sources are important. Now, if you look at the present energy outlook, it's primarily coal, oil, gas, and nuclear, but the renewable energy is gaining momentum now, and it's and the future energy scenario, because we are targeting net zero energy scenario. In that condition, I think in another 50 years from now, it has to be a different energy scenario. So therefore, it is very important for such conditions. We need to come up with an indigenous technologies, Atmanirbhar technologies. So why? Because as far as the energy scene is concerned, the oil is one of the important fuel which is being used across the globe. So therefore, if you look at the resources in terms of reserves, the reserve to production ratio is somewhere about close to 40. That means the global oil can even may last for about another 40 years. Of course, this is highly unevenly distributed across the globe, because some locations are very low and some locations there it's higher value. So therefore, this is an important concern, and it's an alarming that the oil over dependency on oil imports will create a lot of problem, and it also create unrest among the people. So therefore, it is important to look at the resources, and as you know that most of the oil reserves have been peaked in 2005. So therefore, they are limited oil reserves, and we have to come up with the new technologies, the technologies which can drill deeper and deeper. If you go deeper and deeper, we'll get energy reserves, which are resources which can be used for the present energy demand. But then the technology which can cater the needs of the energy demand is important. So therefore, if you look at that, if you go deeper and deeper for oil exploration, as you can see here, the deep is about 1.7 kilometers deeper. Reserves can also be tapped effectively and economically. So future technologies can even make some of these untapped reserves or resources can be explored. But the problem is the environment is a major concern. So therefore, sustainability is an important issue here. So we feel that we deserve for these type of luxurious energy systems. But the technology, as far as India is concerned, because my topic is on indigenous technology development. So therefore, as far as the technology is concerned, if we are over dependent on foreign technologies, obviously there is an issue. Even however much we import the technology, the energy source which fuels the technology is also important. But as you know that as far as the automobile is concerned, we are importing. This is an imported technology, and it is powered by an imported fuel and polluting Indian environment because of proper or improper infrastructure. So eventually, if there is unrest and we may land up into this kind of situation, if there is no supply of the foreign fuel, obviously the sustainability is a major problem. what is happening is the energy sustainability as far as the globe is concerned. We are now experiencing these issues here. So therefore, if you look at the globe, this globe is surrounded by the atmosphere, and we are, because of indiscriminate use of fossil fuels, it is the entire atmosphere is getting imbalanced. That means it's overloaded, and it is we are literally firing off the Earth's environment, imbalancing this by overloading the environment with pollutants. So therefore, any overloaded system will be balanced like this. So therefore, resource sustainability is very important. Resources are limited here, and if there's no technology, you can consume this, and then it becomes empty after some time. Most of the, as I mentioned, the reserve to production ratio for, as far as the oil is concerned, it's about 40 years. And after 40 years, you cannot see any source. So therefore, therefore, it is important to develop an indigenous technology to keep these reserves for the future generation. So therefore, if you develop a technology which keeps the reserves for the future and taking own share here, this is the low-lying, is easy to tap it, but this is difficult to, because you have to develop a technology. This technology, as far as the energy resources are concerned, a renewable energy technology. So that if you develop these renewable energy technologies for local conditions, that's what I mentioned, Atmanirbhar. If you're dependent on your own technology, it's better, and we can save a lot of foreign exchange also. So then the sustainability standard definition of sustainable development is the development that meets the needs of the present without compromising the ability of future generation to meet their own needs. That means you try to use your share of energy rather than using the future generation, because otherwise it will not be sustainable. And generally we don't, we should not consume the future generation's energy as per our requirement. So that's why the future generation says that there is only one Earth we have to take care of. So the energy sustainability can be attained by developing appropriate indigenous Atmanirbhar technologies. So therefore, as a part of this, it's your money, your environment, your mission to ready. We have to conserve the Earth here. Right thing to do is you develop indigenous technologies. So these indigenous technologies are renewable energy or solar energy technologies. And this solar energy conversion, I am giving you as a brief this thing. It can, the solar energy can be indirectly converted into various other forms of renewables. These are other renewables which are manifestation of solar. And there's a solar energy direct conversion in terms of photovoltaics, that is a power generation. The other one is in terms of the heat, the solar energy conversion through heat. So that is a wide variety of applications, including water heating, drying of foods, cooking, desalination, refrigeration, greenhouses, and of course power generation. This is through thermal route. And then the concentrating solar power plants are very important because of their end-use efficiencies. So here you know very well the power plant, thermal power generation by using a heat engine, and this heat engine, the working fluid undergoes cyclic process, and but the heat here, the heat is supplied by fossil fuels, and this heat, if it is replaced by the sun, then it's called solar power plant or concentrating solar power. And the conversion between solar energy to heat by various technologies. These 4 technologies have reached to the stage of maturity: parabolic trough, parabolic dish, linear funnel reflector, power tower. I will quickly explain that how they are, what they are, and how they work. So these 4 technologies have reached to a commercial stage where they can directly supply to the existing coal-based power plants, or you can replace this coal by the solar. So based on the temperature, they are these 4 technologies broadly classified into 2. One is medium temperature, the other one is high temperature. Medium temperature is in the range of 100 to 400, whereas any higher temperature beyond 400 gives you the higher temperature application. These are the two technologies for this and these two technologies for that. At IIT Madras, we are working on various indigenous technology developments through 4D approach: design, development, demonstration, and deployment. So this 4D approach is technology from design to deployment. Of course, the next stage is commercialization with our industrial collaborators. Broadly, the research areas in solar energy at IIT Madras includes concentrating solar power. Just now I mentioned that it's mainly for developing the concentrating solar power technologies, mainly for power generation as well as the green hydrogen production. Then development of receivers for different concentrating solar systems. And apart from that, in this CPV, concentrating photovoltaic system, also an important because the same concentrators can be used for photovoltaics to obtain higher efficiencies, and also used for cogeneration, price generation applications. Another important aspect for the solar energy is the energy storage, because the solar energy is intermittent in nature, so available only during the daytime. In order to extend the operation, or in order to make these systems more reliable, we need to go for energy storage. And of course, the down application could be even solar desalination system. We are actively involved in various applications of the medium and high temperature solar heat, for including desalination. The materials are important for both solar energy conversion as well as the energy storage. So we are also working on characterization of energy storage materials. And it is important to deploy as a part of 4D. Deployment is important in India. So therefore, for deployment of any technology, you need resources. So the resource estimation also important to come up with a viable option at that particular location. So if we look at various technologies covering these 3 or 4 areas, I have listed out here about 20 technologies, and which are indigenously developed through 4D approach. But there are few more also. Maybe some of them are even unpublished, so therefore I am not showing them here. This is our lab and my students. I will quickly show you some of the facilities here. This is solar research facilities at IIT Madras, mainly the concentrating solar power, but I'll also show you the other technologies. So this, if you look at this, this is a parabolic dish, which is point focusing concentrator, which concentrates solar energy onto the point, and it reflects to the focal point. And the concentrated energy is further transformed into heat and then subsequently utilized for various applications, and it produces heat about 15 kilowatts with 640 degrees Celsius. And since it's a point focusing and 3D, so it needs 2-axis tracking here both the ways, elevation and azimuth. And you have we have also this PV system with the tracking, because the tracking system can improve the performance of the PV to some extent, and it is also gives the uniform output throughout the day. Another one is the desalination, which I have mentioned just now, the seawater desalination, converting seawater into potable water. And this is a 2-dimensional parabola, and which is parabolic in this shape and linear the other shape, and this converts solar energy into heat by reflecting the solar radiation, and it requires only single axis tracking to track from morning to evening, unlike the previous one. So it's a simple as compared to this. So but that is why it gives relatively lower performance and lower temperature. And another important thing is a concentrating photovoltaic system. This is a cogeneration system which can produce both electricity as well as the heat, because the concentration of solar energy on PV cells will improve the efficiency, but also simultaneously it heats up the heat, which can be even removed, which can be removed and used for various other applications. So therefore, it's a cogeneration system here. And the solar radiation measurement is also important. And if you look at the another view of these systems, backside view, and as I mentioned that it is a 4D approach. That means it is design, development, and demonstration. So these design, development, and demonstration, all the 3Ds are done in our lab. So therefore, most of these systems are commercial scale systems, so they can be taken easily and directly to the field for the deployment. So therefore, it is a direct adoption of the technology into the field. So our approach, as I mentioned, that 4D, but it is through 4E analysis, energy, exergy, environment, and economic analysis, through 4T mechanisms like test tube to tabletop to technology development. This is a 4T. 4D, 4T, 4D, 4E, 4T. So that's our approach, or our tagline. So then if you look at closely how the concentrating solar system works here, it is a 3-dimensional parabola, and with mirrors. It's a reflective system, and it reflects solar radiation into the receiver. And the design of this receiver, design of the system, and development of this and deploying this is an important thing. And how do we do is our approach is first design of the system, mainly for high temperature, high pressure application, and we developed cavity receivers for absorbing, so it's solar radiation at the focal point. So this is a 3-dimensional parabola. Any ray which is normal to the surface will reflect to the focus, and this at the focal point you have a receiver, or which we call by if you produce steam, it's a steam, it's a boiler here, or if you produce hot water, it's a heater. So this you look at that. This is the design of the. Actually, essentially, there are 3 designs. One is the optical design, thermal design, structural design. So therefore, how optics it works, and how structure works, and how thermal energy conversion is, and this design approach involves both all the 3 approaches: optical, thermal, and structural approach. It is important to come up with an optimal configuration of the system. So receiver plays an important role in thermal system, and when it is exposed to the atmosphere, it loses heat. A major fraction of heat is lost to the environment. So in order to minimize the heat losses, one should come up with an optimal or effective system configuration. So there are various systems have been proposed for different conditions. The same system has to be used for process heat as well as power generation, and also low temperature applications. So these 3 conditions have been considered: superheated, saturated, and subcooled condition, and the temperature ranging from 180 to 500 degrees Celsius, the pressure ranging from 10 to 40 bars. And based on this, these can have a different applications. For example, superheated steam is used for megawatt power generation. Saturated steam is for food and textile industries and steam cooking, other applications. Subcooled steam is used for air conditioning and paper, pulp, and other industries. Most of the process heat is below 260 degrees. Most of the process heat applications are below 260 degrees. These first we do numerical modeling. I'm not going to discuss in detail because we have want of time. So this receiver has been designed and developed through different modelings. That includes this new one of them is a numerical model, and this numerical model is 3-dimensional numerical model of a modified cavity receiver with the different zones of zones, and each of these zones represent subcooled both evaporation and superheating conditions. And we use some neural networks to estimate mainly the overall heat transfer coefficient and heat transfer characteristics in this, and then propose various receiver configurations like this is a parabola here, and then this parabola is used to reflect the solar radiation. So therefore we propose 3 types of receivers, and if these 3 you can see them here and their configuration, and ultimately we estimated the heat losses from the receiver throughout the day from morning to evening with the different configurations. Ultimately it is found that a modified cavity receiver is better configuration for absorbing maximum radiation with minimum losses. So therefore the design of fuzzy focal dish, design and development of fuzzy focal dish is very important here. This is because a parabolic dish concentrates solar energy to the focal plane, but if the parabolic dish is very accurate, it creates a spot, a sun at the focal point. But it's very difficult to make it an accurate parabola with the fragile material like mirrors. So therefore, because of inaccuracies involved in the structure, will result in fuzzy focus rather than the sharp focus. So therefore, you have a wider focal image here. This wider focal image is also good because we don't need the temperatures, very high temperatures. So the medium temperatures are up to superheated condition. We can use the fuzzy focal dish, which means that inaccurate dish. And the receiver design is very important for energy collection as well as, and it should absorb maximum amount of reflected radiation with minimum losses. The losses estimation has been carried out, and moreover, this system is under natural environment, so it is subjected to the gusty and cyclonic conditions. So therefore, it should be structurally strong. And the heat losses, it is also tracked the sun from morning to evening. As it moves, then the heat losses from the receiver also plays an important role here. So these heat losses depends on the geometry, orientation, temperature, wind speed, and wind direction. And the modified cavity receiver is found to be more efficient among the other cavity receivers, and subsequently it is rigorously investigated to find out the heat losses and come up with the appropriate configuration of the receiver. So based on the results, it is found that the dish collector efficiency about 76%, and we proposed an SL number calculations for different dish conditions. Then we also studied radiative convective heat losses from the modified cavity receiver, and accordingly it is presented here. So as we change the configuration, because here the 3 extreme points are taken here. One is the zero inclination condition, that is vertical position theta, and then the inclination is 90 degrees because morning to evening it keeps changing from here to here. So therefore, under different orientation, how the heat losses take place, accordingly we can find out the optimal configuration of the receiver. So this is the study where we have found optimal configuration with the area ratios and so on. But this is one system, it's okay. But if you go for large scale power generation, such dishes are placed in a field, more than several thousands of dishes. But then these thousands of dishes are placed in one location. There is a possibility of casting an image of or shadow of one system on the other one. So here if you look at that, there's one dish here, and then the back side of this dish, another dish is there, and some part of this is shadowed here. So therefore, which has a shadow part here. So that means the dish which is at the back side will produce less energy as compared to the top one, and there is a possibility of hot spots coming here. So we have done a comprehensive analysis for the field for a large scale power generation. What should be the space between two successive or two consecutive systems? Then we in the both direction, east-west direction as well as the north-south direction, and we have studied entire country from Kashmir to Ladakh region, because see it depends on the latitude. So latitude at 8 degrees is Kanyakumari, and 35 degrees is Ladakh Leh region. So in that, how these dishes will be oriented and what is the spacing between these two dishes and so on, you can see we have come up with the operational strategy, and based on this, how to implement this collector field into the power plant. So then for a large scale power generation, and we made an atlas to the entire country for viability of these technology. So this wherever the green colors are there, that is commercially viable. Blue colors are commercially viable under certain conditions, but red color locations are not viable with the present technology. In future, it may become viable. So then we have to do estimation of both convective and radiative losses from the modified cavity receiver, because this I have shown this for some of your students' academic interest. So therefore here we developed Nusselt number for both convection, radiation, and the total Nusselt number, and accordingly these results have been compared with CFD as well as neural networks, and then it proved to be better. And the heat loss is also dependent on the orientation. So therefore, this solar dish should be tracked continuously along the sun, and so based on tracking, the position of the receiver is different, and so therefore we not only that, but also this exposed to open environment. Then the wind blows in different direction with the different velocities. So we need to look at that we have considered three winds, like side-on wind, head-on wind, and back-on wind. All these winds, if the wind comes from the backside, wind comes from the side, and wind comes from the front, how these heat transfer characteristics play a role, and how the deterioration of the losses are involved in this. So based on this, we have come up with a receiver configuration with a different analysis. This is a modified cavity receiver with a complete computational domain, and then you can see the heat transfer of the fluid through a helical spin. And you can look at that the research facilities at IIT Madras. You can see the dish, solar panel, and we have also concentrated on hydrogen, green hydrogen production by using solar energy. The receiver is replaced by the reactor, and in which the methane, which is a biogas, can be used as a feedstock to produce carbon and hydrogen. Carbon is a good byproduct, and hydrogen is now a good fuel. And based on this, we have commercialized the fourth D, deployment. The 4D, the deployment of our technology is done in a pharmaceutical industry here. This is the scaled up version of this. It's about 85 square meters area, which produced 66.5 kilowatt thermal, and subsequently, if you convert into that, another view of that, you can see it's a massive structure, and you can see the people how there is a bigger than that of this 2-story building here, and it's about 10 meter diameter, and the radiation is reflected from the sun here. If sun's position ray is reflected here, and you can see how the concentrated flux is there, and this is the this is the receiver which converts the concentrated solar energy effectively. The another technology is this parabolic trough. Is a line focusing dish because it's a 2-dimensional parabola, and it's a cylindrical on the other direction here, and so therefore this is tracked only a single axis tracking, and the details are given here. And we, in order to study parallel series arrangement, 2 of them are made, and we have come up with a process heat and power generation troughs, which are large, and you can see that they are placed in a CRC classroom complex or 4th floor, and we prepared this foundation and all these. And if you, after completion of the project, this is under construction. If you look at this with this 5.77 meter aperture here, this is used for process power generation. We developed an integrated torque tube box support structure for this, and this is a this means this is a torque tube here, and this is a box structure which is which we have some patents here. And this is a smaller one which can be used for this is about 2.5 meters, and this is almost double the capacity, 5 meters here. And one is used for direct steam generation, the other one is used for process heat applications through thermic fluid. And we installed another technology at in a school with energy storage. This is a linear frontal reflector where the solar energy is focused here onto the receiver here. And this receiver produces steam and which can be stored here and here. So then we are also actually working in indoor experiments to develop this. And the another technology is a linear frontal reflector, where the large long collector field is driven by a motor which can track the sun's rays, and the rays are reflected onto the receiver here. And then this receiver is used to convert the concentrated flux into the heat by circulating some working fluid, whether the working fluid is water or it can be oil also. So here, if you look at if you use as water, this is a massive, and the water goes into the receiver here, and then it goes further, and then takes U shape and come back here and here. And the water is supplied here, and the steam which you are getting at a high temperature, high pressure is this. This is we install in that school, and as a part of our activities. And it's a 50 kilowatt system. It's producing electricity as well. And this is a 1 megawatt. Apart from that, we have also developed further these dish technologies, mainly for process heat applications. We have developed this square and circular dishes, which are used for one is used for CPV. This is CPV applications, and the other one is the process heat, and which is used in an air conditioner here. This is a first of its kind solar vapor absorption air conditioning system. Then the steam direct in CSP systems, their receivers are important, and they involve various components like this: absorber coating, vacuum, glass envelope, glass to metal seal, and absorber stability. So they need to be studied as far as the material characterization is concerned. So this is again a parabolic. I will take another 5 minutes.
Sure.
Okay, is it okay?
Okay.
I'll complete before 10 o'clock.
Yeah.
So this is the parabolic trough collector, and this which you have seen just now, the linear frontal reflector, where here how 4D is used here. That's why I'm showing here how we can do optical, thermal, and structural analysis based on 4D approach here. So each receiver has to be designed for effective conversion in terms of heat and optical point of view. And this is what just now I showed. It's installed in a school where you can see how the support structure and the receivers, implementation and flux distribution with respect to the receiver and the reflectors here. And then we have done a lot of secondary reflective analysis in terms of the thermal modeling, and you can see that about finding out how the temperature contours plays an important role here, and then ultimately we come up with a three-dimensional receiver here. There's another concentrating system which is a passive, which doesn't require any tracking, which is a novel system, which is a 3D non-image elliptical concentrator. I'll show you quickly how it looks like. This is a hyperbolic cross section, but if you look at the view, it's an elliptical here. So based on that, we have to still do again as a part of 4D, we have to do the thermal optical structural analysis. Based on that, this is a thermal analysis of this EHC, that is elliptical hyperbolic collector system, how the flux distribution, temperature distribution is involved, and after that we'll build this EHC. which is an elliptical this, and the receiver is integrated here at the bottom. And we can also, as I mentioned, one of another activities are solar desalination, where the solar energy used to convert the potable seawater into potable water. This is such system. The principle is this, and when it is built as a technology through 4D approach is this. So this is this evaporator and this solar collector. These are the solar collectors which produces pure water as well as some brine which can be treated subsequently. And this is the technologies we implemented, I think. So here you can see the how the solar system is used for effluent treatment, mainly in textile industries. We implemented this in textile industry as well. So how the solar process heat can be used. And another important thing is how to use solar energy for waste treatment, including both solid and liquid waste. We developed a toilet which we call solar zero waste zero waste discharge toilet, neither liquid nor solid discharge. Both will be handled effectively, and solid is recycled and liquid also recycled and used, and it's installed in one of our students' hostel in Krishna hostel in IIT Madras. And we also worked on mobility, solar mobility, solar powered electric vehicles, and this solar electric vehicle is covered with a solar panel, and this complete design has been done here. And an integrated standalone renewable energy system is another thing. How to integrate solar energy with biomass is done in this system. Here the solar panels are 5 kilowatt solar panels are integrated with this, and you can see the integration of both biomass based generator as well as the battery, and then you have an inverter conversion system. And we have done at laboratory all these systems, and of course including this as well. This is structural analysis of all vehicle has been carried out, and it is also compared with the commercial autos, and it's proved that it's economically viable here with a low payback period. And this is another system which is integrated collector storage system, and then you have a tracking system for the PV panels. And because the tracking plays an important role. Apart from that, you have reflective, because all of them are reflective concentrated, but you have a refractor like lens-based system. Also, the solar energy is refracted to a point focusing system. This I have already explained to you on this, because in order to develop solar toilet, the waste needs to be treated. So we developed a human waste conversion into fertilizer through solar system has also been done. This I have shown here. And the another one is the affordable net zero energy building, where you can use solar wind can be used as a part of the building. We are talking about net zero energy buildings. Solid waste can also be treated because this is a conceptual level. So therefore, I'm not giving details here. The wind and both, and it's a portable, so therefore we can move anywhere as per the requirement. It's what we are talking about in India, affordable housing. This will be now a solution for affordable housing. As I mentioned, this toilet. So I think there's some problem. It's again coming back. So now if you come to conclusion here, the indigenous technology development is important for the sustainable development, and 4D approach, as I mentioned, design, development, and demonstration, deployment. But again, I have used C also, commercialization, 4DC. As I mentioned earlier, 4D, 4E, 4Ts are important tools for coming up with indigenous technology solutions as far as the sustainable energy supply is concerned. So with this, I end my talk. Thank you very much. If you have any, I'm from IIT Madras. IIT Madras is a more sustainable campus. A lot of friends like this, and one of my friends is looking at you for these questions. One of my friends. If you have any questions, please ask this person. I'll answer on that person's behalf. Thank you very much.
Thank you, Professor, for this talk. We have few questions posted by the participants. So I will go one by one. For given 3 acres of land, which technology is efficient out of solar PV panels, solar dish concentrator for say 1 megawatt of power generation?
So this question is there in chat box or is
It's in the chat. It's in the chat box.
What is given? I'm looking at that. For given 3 acres of land, which technology is efficient out of PV panels and solar dish concentrators? So efficiency is you're talking about the overall yield. Efficiency is different from the yield. So efficiency means if you have a technology which converts the input, that is solar energy, into effectively output. So therefore, the efficiency point of view, this is more efficient. And as far as the energy yield is concerned, also if you install that dish into 3 acres of land, it will be better as far as the overall yield is concerned. But PV is a different system where it is direct energy conversion. The efficiency of a PV is about 20%, and whereas dish can go up to 60-70% in terms of thermal. And if you look at overall conversion, it will be the comparable. So therefore, for 3 acres of land, depending upon the application, I think I feel the solar dish concentrator is a better yield. Efficiency also better, but yield also good. That's what I feel. So
sure. You can stop presenting, sir.
Huh?
The stop presenting button, no? There you can stop presenting. Yes. Thank you, Professor. We can go to the next question from the chat box. This is regarding the.
I think he has a supplementary thing for 1 megawatt power generation. So 1 megawatt somewhere it requires 4 to 6 acres of land. 3 acres of land for 3 acres of land, I think thermal collectors with LFR, linear frontal reflector, would be better. Okay, next one. Because I'm completed because we have not mentioned that 1 megawatt in the previous comment. Okay.
Yes, so Mr. Nandkumar has also asked about 1 megawatt plant in Coimbatore. How much water is required for regular operation, if you have any idea?
Okay. So one regular operation, what happens is this water is recirculated. It's you are talking about. There are 2 types of water. One is working fluid water. The working fluid water is DM water, demineralized water, which is recirculated, and there is a makeup water requirement, which is about 3 to 4% of the total plant capacity. Whereas the other one is a cooling water. Cooling water, if the water bodies are close by, they generally the cooling towers are used to reject the heat into the atmosphere. Whereas if it's a very dry area, then air is used for cooling the fluid. Like in cooling tower, there are 2 types: dry cooling tower and wet cooling towers. So the water requirements per kg of steam produced depends on the pressure and temperature conditions. But I think it's a bit difficult, but I can give you the range for 1 megawatt water. It will be somewhere close to about 30 to 35 cubic meter cube per minute kind of water requirement. Yeah, I hope you followed.
Thank you, sir. So there is a question by Professor Sudhir regarding how easy is to fabricate helical coil with smooth surface internally.
Okay. The helical coil from a smooth surface. See, when you turn the metallic tube into a circular shape or helical size, what happens? There will be, see, some part is under tension, the other part is under compression, and some stresses are induced. But the better way of, I think he's asking, how do we do that? This can be done in two ways. It can be done in a hydro static way with put a working fluid in some fluid in that and then turn into that. But sometimes there is a leakage problem. The best way is to fill some sand powder and try to make into the helical shape. So it can be easily done. Still the contact surface internally, still it can be smooth. Because if you turn it, there is a possibility of bending and then buckling and other problems may come. But if you fill some material, what is that, cushioning material, you can still keep the internal surface smooth.
Thank you, sir. So what are the major challenges for large-scale implementation of solar thermal energy conversion system, power generation, and process heat needs? Can we foresee megawatt range of solar thermal devices in near future? It's in the chat box.
Yeah. So I think the major challenge, major challenge is the cost. Why solar thermal power generation is not very popular, because it's the major factor is the cost. But another thing is the modularity, because we are looking at the PVs, because they are direct energy conversion, they can be placed even modulars. The modular means the 30 watts to 3 megawatt you can install. So whereas in case of thermal power plants, it's only large scale plants, because you have to go for large scale power generation. In fact, in one of my students is working on a white paper. If we are talking about 2070 net zero energy scenario, in such case, what will happen to the existing coal-based power plants? Now you have seen the coal-based power generation is about 60 to 70% in India. That 60 to 70%, if they have become zero, then what will happen to the infrastructure which is available with these power generation or power plants? Then we are coming up with different approaches. That one of the approaches could be the integration of CSP into that. Apart from that, the cogeneration options, the co-firing options. So therefore, I hope the major factor is the cost, but in future definitely it is going to be important technology for the future. By the reason being is replacing the coal-based power plants, and not only that, energy storage integration, because in PV plants the energy storage is a major concern, and it is connected to the grid. So therefore, there is a possibility of failure if you put so many injection points into the main grid. What will happen? There is a grid instability. So that can be avoided by appropriate energy storage technologies. In terms of thermal energy storage, once this thermal energy storage is developed commercially, this CSP will pick up. I think it's still picking up, now slowly picking up in various European and US. As far as India is concerned, I think as far as my knowledge goes, there are 3 bigger plants are located in India, and one is working in one of our industrial associates is working. That is a Reliance plant. It is about 125 megawatts in Pokhran in Rajasthan. You can check that in Google Map. It's a massive system. So that's 125 megawatts. It's based on linear frontal reflector. And there's 150 megawatt power plant in Anantapur, and another one is in this 50 megawatt plant is a mega engineering plant, and there's one more in I think Madhya Pradesh. So these are that. So therefore, there's a future for CSP.
Thank you, sir. So this is a related question. Existing industries are having the problems of less area availability and difficulty of integrating with existing systems and uneven supply of heat from solar collectors. So how to install parabolic trough collectors or dish collectors in industries because of the area to remove the challenges.
So the area is a major concern. But what happens is for process industries, I recommend the parabolic trough collectors as compared to the dish. Because even I have not shown the implementation side, because some of our industrial associates, they implemented these technologies to various industries, including dairy, paint industry, and leather industries, and other process industries like textile. The parabolic trough collectors can be even now lightweight roof mounted, because you have seen now all logistics parks are very massive, and the rooftop can be utilized for these process industries where the space is a constraint. And this lightweight parabolic trough collectors can be integrated along with the roof and with the minimum loads. So it has been done. Today I have not shown, but one of our industrial associate has already implemented that. It's a roof integration, a lightweight parabolic, and we are talking about micro and small scale parabolic troughs, which are not away from because if you go for bigger parabolic trough collectors, what happens? They have to be structurally stable. And when any solar system, if you go away from the ground, away from the gravity, so it will have to be structurally strong. So therefore, once you go for structural strength, obviously the cost will go up. So you try to make it smaller and close to the ground or close to the roof, so that it's also structurally stable. Still, it can produce equal amount of energy. So that way, parabolic trough collector can be integrated with the process industries where the area is a limitation.
Thank you, sir. So we'll take the last question due to lack of time. So, is there any opportunity of applying machine learning in forecasting solar energy production?
Correct. I think it's plenty of opportunity. Even now, two of my students are working on ML and AI in resource estimation, because you know that it's an interesting question, because see, we use statistical methods like neural network for estimating the resources. But now if you use AI or ML, because the main problem with these renewable, including wind and solar biomass, the resource estimation. And this resource, especially solar and wind, they are transient in nature. Every minute it keeps changing. Then what happens is when the plant is connected to the load, the load prediction as well as this resource prediction is a very complex, because suppose after 15 minutes, if a plant is connected to a load and after 15 minutes the load is going up, then how do we match the input to match the load? Then that is a challenge. Or the vice versa. Suppose after 15 minutes there will be a cloud cover. Then how do you account that in your load dispatch? So therefore it's important to use the AI and ML for predicting the real-time solar resources, not the future. Maybe estimation of solar energy tomorrow can be done with statistical analytical. But after 15 minutes, what is going to be the solar radiation? What is the cloud cover? What is the, in case of wind, what is the wind direction and what is the magnitude of wind? This can be done through ML. So therefore, there is a huge potential in future. I think these tools can be effectively utilized to make these systems more efficient and better, to give better yields. Thank you.
Thank you, Professor. Because of in the interest of time, I think there are many other questions and so we will take it offline. Thank you, Professor, for this insightful talk. On the behalf of the participants, we would like to heartily thank our guest speaker for the TREATS talk number 13 for his invaluable time. We also thank the audience for their questions and for this interactive discussion. We thank you and have a nice day ahead.
Thank you very much. All the best, and I also
Thank you.
congratulate for this, and I also all the best for future programs as well. Thank you very much.
Thank you. Thank you.